Okay, number 9. This is section 3.3, chapter 3, geometry review. We've already done 1 through 8. First thing we want to do in section 3.3 is we found ways to prove that lines were parallel by finding values that make relationships between angles true. In the case of this problem, we have the x and the 73 that's sitting here are related as consecutive interior angles. And what we know is about consecutive interior angles is that they're supplements. And if they're supplements, then they add to 180 degrees. And so if I add these together, take 73 away from both sides, x is actually 107 degrees. Number 10. When I look at the relationship between the angles in number 10, what are they called? On the outside of the parallel lines, opposite sides of the transversal, makes them alternate, and they're exteriors. Now in this problem, they just said find the value of x, but I think it's hugely important that we go through the relationship, identifying the relationship, because in the case of consecutive, these are the ones that are supplements. Alternate interior angles need to be congruent though. So if alternate interior angles need to be congruent to show that lines are parallel, then I'm going to set these two values equal to each other. 147 equals x plus 14. And then to solve for x, I'm going to take 14 away from both sides. X is 133. Alternate interiors for number 10. This one's interesting. For sure interesting. Now, when I look at number 11, it actually, the way this is written is really small. That 2x plus 20 is sitting in this upper corner, and I kind of highlighted it with yellow. It's sitting up here. This 2x plus 20 is sitting here. And then I look at 3x, and there's not a relationship between where 2x plus 20 and 3x sits. But there's something that I got going on that I can, I'm recognizing that 3x right here, I could put it on this angle as well because of vertical angles are congruent to each other. And so I'm actually going to come on my paper and I'm going to draw what I'm showing you here because I think for this problem it's important that we recognize. I'm just going to draw, what do I got? I'm going to make this a little bit wider too. So there's my M. Do the same thing on your paper. This will help you. They put the 3x down here and the 2x plus 20 sits here. So my point is if this angle is 3x, so is this one. Now, why would I want to go do that? Well, I got to create some kind of angle relationship so I can figure out what the x value is. And now that I've gone and said these two angles both are 3x, what I can do then is, these are consecutive interiors. And again, consecutive interiors are supplements. So using the idea of vertical angles, I've now set myself to where I have 2x plus 20 plus those 3x's have to equal 180. 2x plus 20 plus the 3x's have to equal 180. And then I'm not undoing yet because on the left side of the equal sign, I still have to simplify and put together like terms. 2x's and 3x's is 5x. Put it away. 5x plus 20 is 180. Then I'm going to go through the process of solving. Subtract 20, then divide by 5. If your calculators aren't open, get them open. Number 11, nothing. Where's your work? Where's your work? Get a piece of paper. This is due tomorrow. When are you going to do this? Now. Taking 20 away, I got 160. 5x equals 160. Dividing by 5, what'd you guys get? Perfect. So that one had a lot going on. I'm not saying that I'm going to try to trick you on the test, but you got to be prepared. to, you know, maybe have to work out something that has, I've got to draw some conclusions like I did here by having to put my 3x as the vertical angle. So bottom line is, I've said it before, it ain't all cut and dry. High school geometry, there's going to be some challenges. Now, number 12, when I look at number 12 in the drawing, these actually are sitting corresponding spots. Those two angles are sitting in corresponding spots. So what I'm going to do then is set them equal to each other. Corresponding angles are congruent. I'm going to write down here that these guys were corresponding. And corresponding angles are always congruent. So 7x minus 11 equals 4x plus 58. And then I have to, there's nothing to simplify on the left and right. So I'm going to go right into undoing. I'm going to start by taking 4x's away from both sides. 3x's minus 11 equals 58. Go ahead and add 11 and divide by 3 to get to your final answer. Add 11, divide by 3. When I add 11, I get to 3x's equals 69. When I divide by 3, x is 23. I think that wraps up 3-3 work. Let's go on to the 3-4. Now in 3-4, I need to be in my, well, I don't have it, but your pink notes packet is where you go for this. Can we decide? Can we decide if there's any parallel lines? Now, in number 13, the fact that line X and line Y are both perpendicular to line Z gives us, we've done this a bunch of times, X is parallel to Y because line X and line Y are both perpendicular to line Z. And what theorem is it that allows us to say X and Y are parallel? 3.2? 3.12. Go looking. You guys should have this. And again, actually, oh, I don't know if I told you this yesterday, but I did put on your test, I'm going to use your test, on your test on the front is a whole bank of all the theorems. So you got to use a theorem. There's a box that has them all listed there for chapter 3. So you need to know which ones go looking for. In the case of this one, in a plane, if two lines are perpendicular to the same line, then they're parallel to each other. 312. There you go. Demia had it. So number 13, there's that explanation. I'm going to put my, this is all 13. Now let me go over to 14. I'm looking to see, boy, can I say X and Y are parallel? I could if they were both perpendicular to the same line, but they're actually perpendicular to different ones. I could if they were both perpendicular to the same line, but they're actually perpendicular to different ones. So can I say W and Z? Are they both perpendicular to the same line? Nope, they'd have to both be perpendicular to X or both be perpendicular to Y. So in this case, I can't say that any of them are parallel. Y and Z, parallel means they never intersect. Y and Z intersect. Now, let me go ahead and look at a lot going on in 15. Whole lot going on in 15. I think I can do some parallel lines in 15. I really do. Because when I focus on, let me go first to where I see, you guys see that M and N are both perpendicular to A? Yeah. So I can actually say, and your argument needs to be detailed like this, I can say then that M is parallel to N because line M and N are both perpendicular to which? Line A. And so it's theorem 312, again, that reads, in a plane, if two lines are perpendicular to the same line, then they're parallel to each other. M and N are parallel to each other. Now, how about looking at these A and B? A and B. And I know I've drawn some stuff in here already. But do I have A and B perpendicular to the same line anywhere? I think I see it at N. Yeah, if I go in and look at A and B, I see A perpendicular to N, B's marked perpendicular to N. So I'd have to go on and say, okay, same kind of argument. A is parallel to B because line A and B are both perpendicular to line N. And again, I'm dropping in theorem 312. I think I could stretch this and talk about possibly that L might be perpendicular to M, but I'm satisfied with identifying these two pairs right here. Moving over to 16. My question for you guys is this. If you focus on line N, focus on this single line N. What two lines are both perpendicular to N? A and B. So I just kind of talked about this in reverse. Talked about it in reverse. I said focus on this line because I saw a place where there was two lines perpendicular to it. So A and B, in this case, let's see, N intersects both A and B at right angles. So A is parallel to B because they both are perpendicular to N. And again, theorem 312. All over again. In a plane, if two lines are perpendicular to the same line, then they're parallel to each other.
So when you find a perpendicular one, are you looking for a certain, like for this one, so you'll be looking for a certain one that's perpendicular, so that's the one you focus on?
You look at a place where they're perpendicular. Do you have that, Jacob? Yeah? Okay. I didn't see it on your desk. You're looking for a place where on a line you can see two perpendicular lines to it. That means those two are parallel. Like, let me go back up to 14. You know, like when I look at line Z, just focus on Z. I'm like, is there anything where, are there two perpendicular markings going along Z? No, there isn't. That's not going to help me. Along W, any two perpendicular markings along W? There isn't. Any two along X? None of them. Y? None of them. So does that help kind of with the thinking process, line by line? So then if I look at, okay, I started us out saying, all right, line N. Oh, watch, two of them right there at line N. That's what made me identify AB. Now, any two lines, because we're going to finish this problem with that same line of thought. Any two lines perpendicular to M? Just one. So I only, just one, and I need two to be able to say parallel. So I can't get anything out of that. Now let me focus on line A. Two lines perpendicular to A? Nope, that doesn't help. Two lines perpendicular to B? That doesn't help. Are there two lines perpendicular to C? Nope. So the only place where two lines were perpendicular to the same line was N. And this is the only conclusion I can draw then.